Factoring by grouping is something that we can utilize when we want to factor a polynomial that has four terms. So I have four steps here for you to follow every single time you want to factor by grouping. Step one, anytime you're factoring, you will always check to see if there is a GCF. No matter if you're using grouping or what we learned down the road, something like split the middle, you're still always going to look for a GCF first. So I'll go through and do a couple of problems as we learn these steps. So looking at number one, 4n cubed plus 8n squared plus 5n plus 10. If I look for a GCF, that means that every single term, since there are four of them, all four have that factor. Well, 4, 8, 5, and 10, the only number that they're going to have, the only common factor is going to be a 1. So that's not going to help us. And then looking n cubed, n squared, n, and the fact that this term doesn't have any n's, there's not going to be a GCF here. So step one is already done. Step two, we're going to group the first two terms together and the last two terms together. So this is not anything technical here. I usually just kind of do this to kind of say, okay, here's my first group, here's my second group. Or sometimes I draw a little squiggly down the middle just to visually show myself that I'm working with two groups. So this first group right here is 4n cubed plus 8n squared. Okay, the second group is positive 5n plus 10. So we have our first two terms and our last two terms. We have grouped. This is why it's called factoring by grouping. So the third step is to factor out the GCF from each group. The binomials inside the parentheses should be the same after you've done that factoring. So here's what I mean. The first group, 4n cubed plus 8n squared, the GCF of those two terms is 4n squared. So if we factor 4n squared out, then in the parentheses, we would have 4n squared times what is 4n cubed? That would be n. 4n squared times what is 8n squared? That's going to be plus 2. Now, if I do the same thing over here, 5n plus 10, the GCF there is a positive 5. So I'm going to write plus 5. And then in these parentheses, 5 times what is 5n? That's going to be n. And 5 times what is 10? That's going to be plus 2. Notice that this now looks kind of like what we were working through in our previous class. So we were looking at factoring by grouping. We noticed that, okay, out of this section here and this section here, they each have that common n plus 2 quantity. So that n plus 2 is like acting like a GCF. So we factor out the n plus 2. And then what's left in these parentheses is this stuff that's still out front. Because if you factor n plus 2 out of this group, you're left with 4n squared. And if you factor n plus 2 out of this group, you still have positive 5. So this is now a product of two binomials. So since it's a product of polynomials, we have factored number one. So if you want to check your answer, which I think is always a great idea, you would go through and multiply your binomials, right? N times 4n squared is 4n cubed. N times 5, that's plus 5n. 2 times 4n squared is plus 8n squared. And 2 times 5 is plus 10. Now, this isn't written in the same order, but if I were to rewrite this in standard form, I would get back to the original problem, which means we did the question correctly. So let's try one more. Number 2, again, our first step is to look for a GCF. So out of 12p to the fourth plus 10p cubed minus 36p squared minus 30p, I can see that there is a GCF for all four of these terms, and it's going to be 2p. So if we factor 2p out, then inside I'm still going to have four terms. We would have 6p cubed plus 5p squared minus 18p minus 15. Now, for a moment, I'm going to go ahead and ignore the 2p, but this still is important. It has to be part of my final answer, so it doesn't just go away. But for a moment, I want to just focus on our four-termed polynomial here to continue with our steps. So we're going to group the first two terms and the last two terms together. So 6p cubed plus 5p squared gets grouped, and then negative 18p minus 15. So out of this group of two terms, what's the GCF? Well, 6p cubed plus 5p squared looks like the GCF is p squared. So if I factor that out, we have 6p plus 5 in the parentheses. Now, my goal up here, remember, it says the binomials inside the parentheses should be the same. My goal is to have this happen over here. So negative 18p minus 15, if I'm thinking about the GCF there, a lot of times we're going to say, oh, well, it's 3. So if I factor out a positive 3, what I'm going to get here is negative 6p minus 5. Now these parentheses, they don't match. But what if instead of positive 3, if I had factored out negative 3? So if we factored out a negative 3, that's going to change the inside of these parentheses here, and it's actually going to help us. So if I factor out a negative 3 instead, negative 3 times 6p is negative 18p, and negative 3 times 5, positive 5, is negative 15. Now I have a quantity of 6p plus 5 out of each group, which means we would factor out the 6p plus 5, and the second set of parentheses would be the binomial p squared minus 3. So this would be our final answer, one binomial times another binomial. And again, if we wanted to check our answers, we could multiply the two binomials. 6p times p squared. Oh, wait, hold on. We made a mistake. I forgot. The one thing I said, don't forget, and then I forgot about it. That 2p at the beginning, that's still part of our answer. So that's going to go right here in front. Whew, I almost forgot that. Clearly a very common mistake. But now we could do the check. Now, when I do the check, I would go ahead and maybe distribute the 2p into this first set of parentheses. So the first set of parentheses would become 12p squared plus 10p. And then we multiply that by p squared minus 3. So if we do that, 12p squared times p squared is 12p to the fourth. 12p squared times negative 3 is minus 36p squared. 10p times p squared, that's plus 10p cubed. And 10p times negative 3 is minus 30p. Again, it's out of order here, but it does match what we have up here, and that would check. If I had only multiplied the 6p plus 5 and p squared minus 3, I wouldn't have gotten back to this because I would have been missing that 2p. So that's why the check is so important. If I hadn't done that, I probably wouldn't have noticed that I was missing part of my final answer. So my final answer ends up being a monomial times a binomial times another binomial.